All right, let's dive into this. Some interesting YouTube tutorials you sent over, not your typical machine learning stuff. We're talking like building algorithms from scratch using C++. plus plus.
Yeah, it's pretty refreshing, right? I mean, we see TensorFlow and all these frameworks, but um, you kind of lose sight of what's happening under the hood. So this is really getting back to basics.
Exactly. It's like learning to cook before you even think about using a microwave. We're diving deep into handwritten digit recognition with the MNIST dataset. It's like
Mm.
teaching a computer to see numbers like we do.
Yeah, a classic problem.
Yeah.
Lots of practical applications too. What I find really cool is that these tutorials, they're using only standard C++ components, no external libraries, so it really forces you to understand the underlying processes.
So C++I. Most people think Python when they think machine learning. What are the advantages of going the C++ route here?
Well, Python's great, easy to use, tons of libraries. But C++, it really shines when you need performance efficiency. And since you're building everything from scratch here, you have so much control over how the code runs. You can really optimize for speed and memory, which can be super important with these large data sets.
And speaking of data, the first tutorial dives right into handling the MNIST dataset, building that foundation.
Absolutely. Before you can even think about training a model, you need to really know your data, inside and out. And the MNIST dataset, it's thousands of handwritten digit images. Each one is 28 by 28 pixels.
The tutorial author mentions the data is stored in binary format, specifically big endian. Why is that so important?
Well, that's a good point. Data often needs to be pre-processed before you can even use it for machine learning. And this big endian format, it's a way of storing data that it might not be compatible with your computer's architecture. It's like trying to follow instructions in a foreign language. You need to translate them first.
So the first step is kind of like translating the data into a language that the computer understands. What else is involved in this whole data handling process?
Well, the tutorial goes through reading those binary files, separating the image data from the labels, making sure everything's in the right format for your processor, like sorting through a box of old photographs and carefully labeling each one.
And the tutorial also stresses the importance of splitting the data into training, testing, and validation sets. Why is that so crucial?
Imagine you're studying for an exam. You're not just going to cram the whole textbook and then go take the test,
Yeah.
right? You need to practice, see where you're at, identify any weak spots.
So the training set's like the textbook, the validation set's the practice quizzes, and the testing set, that's the final exam.
Exactly. The training data, that's what your model learns from. The validation set helps you fine-tune the model, avoid overfitting, and then the testing set, that gives you an unbiased evaluation of how well your model will actually perform on new data that it hasn't seen before.
Okay, so the data is prepped and ready to go, and that's where the second tutorial comes in. Introducing the k-nearest neighbors algorithm, KNN. Seems like a pretty intuitive way to classify things.
It is. Imagine you have a new handwritten digit, say a 7, and you want your algorithm to classify it. Well, KNN compares that new 7 to all the other 7s, 1s, 9s, and so on in the training data.
So it's looking for the most similar examples.
Exactly. It finds the K most similar images, and it does this based on their pixel patterns. And it basically takes a vote. Whichever digit appears most often among those K neighbors, that's the algorithm's prediction.
And the tutorial mentions distance metrics for comparing these images. It highlights Euclidean distance, that's like the classic straight line distance. But it also touches on Manhattan distance.
Yeah, think of it like navigating a city. Euclidean distance is like flying straight from point A to point B. Manhattan distance is more like traveling along the city blocks. You only make right-angle turns.
So instead of cutting across a park diagonally, you're walking along the edges.
Exactly. The tutorial uses Euclidean distance for their KNN implementation. But it is good to know that different distance metrics exist, and they can definitely influence how the algorithm sees similarity.
The author points out that KNN can become computationally expensive, especially with those large data sets, if you calculating distances every time. So how does the tutorial address that?
Yeah, that's a challenge with KNN. In this case, the author pre-calculates all the distances and stores them. It's basically trading memory for speed. It's
Yeah.
like having a map of the city ahead of time, so you don't have to keep recalculating routes every time you need to go somewhere.
Smart. So even a simple algorithm like KNN, it involves a lot of optimization consideration.
Oh, absolutely.
Yeah.
And another crucial factor is choosing the right K value, the number of neighbors you consider.
And the tutorial shows how you can play around with different K values to find that sweet spot, right?
Yeah, exactly. If K is too small, your model might overfit the training data. it won't perform well on new data. If K is too large, it might miss some subtle patterns.
So it's all about balance. Now let's talk results. The author gets some pretty impressive accuracy with his C++ KNN implementation.
It is pretty remarkable. Even with this relatively simple algorithm, he's getting accuracies that rival some of the more complex algorithms listed on the MNIST website.
And he even points out some cases where the algorithm makes mistakes that, like, we as humans would probably struggle with too.
Yeah, it's a reminder that image recognition is a tough problem. And what might seem obvious to us, it might not be so clear-cut for a computer just looking at pixels. It's those edge cases where the algorithm trips up that's fascinating.
Definitely sheds light on the nuances of image recognition. What struck me was just how much coding is involved. Even for a simple algorithm like KNN, building it from scratch, it takes a lot of attention to detail, a solid grasp of programming concepts.
That's where the beauty of C++ shines. It gives you that fine-grained control, everything from memory allocation to those data structures. That level of control can be really valuable when you're looking for that peak performance.
And the tutorial, it's not about just blindly following the code. The author really explains the reasoning behind each step, which is so important for understanding the concepts.
It's not about replicating, it's about understanding. The author encourages you to think critically, to maybe consider how you might even improve on the implementation. That's what fosters deeper learning.
Yeah, it reminds me of learning to cook. It's one thing to follow a recipe, but understanding why each ingredient is there, why you use certain techniques, that makes you a better cook in the long run.
Precisely. Once you have that knowledge, you can start experimenting, you know, making your own variations and optimizations. And the author even hints at implementing different distance metrics, which I think could lead to some pretty interesting results.
The possibilities are exciting. It makes you think about how this hands-on approach compares to using these pre-built machine learning frameworks. Frameworks make things easier, but there's a real satisfaction that comes with building something from scratch.
Absolutely. There's a sense of ownership,
Yeah.
you know, a deeper understanding. You're not just plugging in data and hoping for magic to happen. You're actively involved in the whole process.
And it demystifies machine learning. These algorithms, they become less like black boxes and more like tools that you can actually understand and manipulate.
That's a really crucial point. When you work with pre-built frameworks, it's easy to fall into that trap of treating them like, oh, this is some magical solution. But you don't really understand what's happening under the hood. But when you build it yourself, you have to confront the complexity. You have to grapple with those nuances. And that leads to a much deeper, more profound understanding.
Yeah, it's like the difference between driving a car and understanding how the engine works. You get a whole new level of appreciation when you know what's going on under the hood.
Exactly. It's like these tutorials are giving you that mechanic's guide to machine learning. You're not just driving the car. You're learning to build it, maintain it.
And while they focus on C++ing, the concepts, the principles, it's all transferable to other programming languages as well. So even if you're not like a C++ guru, there's a lot to gain from this.
Yeah, the fundamentals of machine learning, they go beyond any particular language, right? This gives you that solid foundation that you can apply to Python, Java, whatever you choose.
It's like learning the rules of grammar. Once you get the basics down, you can apply them to different languages, different writing styles.
Exactly. Those core principles are always there.
One thing I really like about these tutorials is just how clear and concise they are. He explains these really complex concepts in a way that's easy to follow, even if you're new to machine learning.
It's a very engaging and effective teaching style. He does a great job of balancing the explanation of the theory with, the actual practical implementation. It's like having a mentor who's patiently guiding you through the process. Very knowledgeable.
I agree. And the way he structures the code, breaking it down into these smaller pieces, it just makes it so much easier to understand how it all flows together.
Yeah, that's good software engineering, right? Breaking a problem down into those smaller modules
Yeah.
makes the code easier to read, maintain, but it also just helps the understanding.
Like building a house. You start with the foundation, then you add the walls, the roof, and all the finishing touches. It's all building on what came before.
And just like a well-built house, well-structured code, it's robust, reliable, easy to modify or extend later on.
And speaking of extensions, these tutorials are a great starting point for, further exploration. You understand the basics of KNN, then you can start experimenting with different variations, optimizations.
Yeah, the possibilities are endless. Different distance metrics, ways to handle noisy data. You could even delve into more advanced algorithms.
Exactly. And one thing he suggests is actually comparing your C++ implementations to existing frameworks like TensorFlow or PyTorch. I
Yeah.
thought that was a really cool idea.
Yeah, it's a smart way to bridge the gap between theory and practice. You get to see how those concepts you've learned actually translate to the tools that are being used by, professionals in the field.
Like learning to build a car from scratch and then being able to really appreciate the engineering that goes into like a modern automobile. You understand those complexities, those trade-offs, the design choices.
That's a great analogy.
Yeah.
And these tutorials, I think they really highlight that machine learning, it's not this mysterious thing. It's not some black magic that's only for, a select few. It's something that anyone can learn if you have the curiosity and the dedication.
Yeah, absolutely. And with resources like these tutorials, I mean, the barrier to entry has never been lower.
It's such an exciting time to be exploring this field.
Yeah.
And these tutorials, they're that perfect launch pad, not just for the technical stuff, but they also cultivate that mindset, you know,
Yeah.
curiosity, exploration, that desire to understand how things work at a deeper level.
Yeah. It's like he's saying, here you go. Here are the tools. Now go build something amazing.
Right. That's what's so cool about it. It's like you're not just a consumer of machine learning, you can be a creator.
And C++ say. It's interesting that he chose C++ say. You know, you don't need the latest, fanciest tools to get started.
Yeah, C++, it has a certain, I don't know, elegance to it. You get to see those nuts and bolts, like building a clock from scratch instead of just, setting the time on a digital display.
Exactly. And that deeper understanding, you can take that to any language or framework later on.
Oh, for sure. Like music theory.
Right.
Learn the fundamentals, and you can apply that to
Oh.
any instrument, any style of music.
Yeah, the core principles are the same. These tutorials, they give you that adaptable skill set.
You can use it throughout your whole machine learning journey.
And it just goes to show that machine learning, it's not some exclusive club, right?
Right.
It's something that anyone can learn if they're curious and willing to put in the work.
And with resources like these, I mean, it's never been easier to get started.
So what does all this mean? We've seen how to build a machine learning algorithm from scratch using a language like C++ that really gives you that efficiency and control. We talked about data handling, distance metrics, the importance of optimization. But I think most importantly, we've gained this deeper understanding of the fundamentals of machine learning. And that's something you can apply no matter what language or framework you use. And this deep dive, I think it's given us the knowledge and hopefully the inspiration to keep exploring this amazing field. Who knows what we'll create, right?
Yeah.
With these new skills.
Yeah, it's been a great deep dive. We've seen how powerful C++ can be, the elegance of KNN, and really just the endless possibilities for anyone who's ready to, jump into machine learning.